All right, so here we are, section 2.1, starting off looking at something called a conditional statement. A conditional statement is a statement that has two parts. It has a part that we call the hypothesis and a part we call the conclusion. When the statement's written in if-then form, the if part contains the hypothesis and the then part contains the conclusion. So we're talking about a statement that starts off with if, and in the middle it says then this happens. So, an example, if it's noon in Georgia, then it is 9 a.m. in California. So, the if portion is the hypothesis, the then portion is the conclusion. So, we want to take these next few statements and rewrite them in if-then form so that we can turn them into a conditional statement. So, first one says all mammals breathe oxygen. And so to put that in if-then form, it's going to look something like this. If an animal is a mammal, then it breathes oxygen. All right, so we added a few words in here just to make it flow a little bit better. And so if an animal is a mammal, then it breathes oxygen. So a lot of people will just put if it is a mammal, something like that. We want to be a little bit more specific, make the statement sound a little more descriptive about what we're talking about. So try to avoid it or its in these statements. So the next one, all monkeys have tails. So we're talking about monkeys, and I want to say if something about a monkey. So if it is a monkey, see, that's not quite descriptive enough. So I'm going to start off with if an animal is a monkey, then it has a tail. So moving on, writing a counterexample. Right, we have discussed counterexamples in the last chapter. Counterexample is an example that proves that a conditional statement or that the statement that we're making is false. So if a number is odd, then it is divisible by 3. So to make a counterexample of that, we just need to find an odd number that would not be divisible by 3. So we could go with the number 5 and say 5 is not divisible by 3. And there's a whole multitude of other numbers we could pick from. That would be odd and not divisible by 3. We do 11, we do 17, 23. So now, once we have a conditional statement in if-then form, then there are several variations we can make on that statement by switching the hypothesis and conclusion and changing a few other things. So one such different format is to say the converse. Right, the converse of a conditional statement is formed by switching the hypothesis and conclusion. So what is in the if part, which we call the hypothesis, switches to the then part, and the then part, which is the conclusion, switches to the if part. So if our original statement is if you see lightning, then you hear thunder. So in this original statement, you see lightning is our hypothesis, you hear thunder is our conclusion. So now we switch those around to create the converse, and now it's if you hear thunder, then you see lightning. So lightning goes to the end, thunder goes to the front. So that's a converse. The inverse is a result of altering the hypothesis and conclusion by something we call negation, which is basically writing the negative of the statement. Which, if we're talking about an inverse, what we're talking about is putting in words like not. If not this, then not that. And then a contrapositive is the result of negating the hypothesis and conclusion of the converse of a conditional statement. So converse switches the order, puts the conclusion in the hypothesis and the hypothesis in the conclusion. Inverse doesn't change the order, it just takes the original statement and puts negations into it, or puts the word not into it on both ends, the hypothesis and conclusion. And then the contrapositive takes that inverse, or takes the converse that has flipped the hypothesis and conclusion and negates that. So converse switches them, inverse inserts not, and the contrapositive switches them and inserts not into the statement. So examples here: original statement or conditional statement. If the measure of angle A equals 30 degrees, then angle A is acute. Inverse of that, it's going to say if the measure of angle A is not equal to 30, then angle A is not acute. All right, so we've put not into both ends of the statement, making it an inverse. Converse, or the converse switches the order. So taking what's on the end here and putting it at the front, and what's at the front goes to the end. If the angle A is acute, then the measure of angle A equals 30 degrees. And then the contrapositive basically takes the inverse and the converse and puts them together in one statement. So if angle A is not acute, then the measure of angle A is not equal to 30 degrees. So we've taken the order that it's in for the converse and put the knots into both parts. Alright, so next up we want to write the inverse, converse, and contrapositive of the following statement. So it says if the amount of available food increases, then the deer population increases. So if there's more food available, then there'll be more deer. That's basically what the statement's saying. So if we make the inverse of that, the inverse has to put not into the statement on both ends. So if the amount of available food does not increase, then the deer population does not increase. Right? So we put not here and not here. Converse, when we just switch the order. So deer population is going to be at the beginning, available food is going to be at the end. So switch those around, and we have to make this statement make sense once we switch everything. So sometimes we have to switch a few words. Right. So if the deer population increases, then the amount of available food increases. So deer population was at the end, now it's at the front. We're in the hypothesis, and available food was in the hypothesis at the front, and now it's at the end in the conclusion. And the last one, the contrapositive, and we're going to take these two statements, turn them into one statement basically. And so if the deer population does not increase, then the amount of available food does not increase. All right, so then here we just have a list of a whole bunch of new postulates to add to our toolkit. All right, all about points, lines, and planes. Through any 2 points, there exists exactly one line. All right, so if I have any 2 points, there is exactly one line that I can draw that goes through those 2 points. And a line is going to contain at least 2 points. So if I've got a line, then there has to be at least 2 points on that line. Right. Postulate 7, if 2 lines intersect, then their intersection is exactly 1 point. Right, so if I have two lines intersecting, then where they intersect is just 1 point. Postulate 8, through any three non-collinear points, there exists exactly one plane. So if I have 3 points that are not on the same line, then there is one plane that would hold those 3 points. A plane contains at least 3 non-collinear points. So it's just kind of the converse of this one. If we have a plane, then it has to contain at least 3 non-collinear points, or it's not a plane. All right, postulate 10. If 2 points lie in a plane, then the line containing them lies in the plane. All right, so if I had a plane here, and I've got 2 points that lie on that plane, here and here. If I draw a line that goes through those 2 points, then that line would also be on the plane. And 11, if 2 planes intersect, then their intersection is a line. So if I have 2 planes intersecting, then where they intersect, if I can draw the line in there right, that intersection would be a line there. So something like that. So on to the next page. So I want to use this diagram to give examples of postulates 5 through 11. The postulates we just went through. All right, postulate 5 says through any 2 points there exists exactly one line. So any 2 points. So in this picture, there's only one line that I have drawn that has 2 points in it. We've got line N, which has A, B, and C in it. Line M only shows point B. So I want to talk about line N and say that there is exactly one line, known as line N, that goes through A and C. One line going through points A and C. So then postulate 6 says a line contains at least 2 points. So line N contains at least 2 points, doesn't it? We got point A, we got point B, we got point C. Just have to highlight 2 of those. So line N contains at least 2 points, A and C, or could have said A and B. Postulate 7, if 2 lines intersect, then their intersection is exactly 1 point. So we have 2 lines, line N and line M. They're intersecting at 1 point, and that point is B. So we would state that M and N intersect at B. So line M and line N are intersecting at 1 point, point B. And postulate 8, through any 3 non-collinear points, there exists exactly one plane. So 3 non-collinear points. So A, B, and C are all on the same line, so they're collinear. So we have to include D. We're talking about 3 non-collinear points. And so this is plane R. So we can say that R passes through 3 points, D, A, and C. Or we could say D, A, and B, as long as we put D in there, because that's the only one that's not on the line. Postulate 9, a plane contains at least 3 non-collinear points. So plane R contains at least 3 points, right? D, 3 non-collinear points, D, A, and C. And postulate 10, if 2 points lie in a plane, then the line containing them lies in the plane. So we've got point A and point C that lie in plane R, and so therefore line N is going to lie in plane R as well. So A and C lie in R, which A and C lie in R, so N, which contains A and C, also lies in R. And then lastly, postulate 11, if two planes intersect, their intersection is a line. So when we look at the picture, we have plane S, plane R, intersecting at line M, which meets that rule. So R and S intersect in line M. All right, write the inverse, converse, and contrapositive of postulate 6. So a line contains at least 2 points. So before we can write it as an inverse, converse, and contrapositive, first we have to write it as an if-then statement. So to go to an if-then, once again, we have to add a little bit of stuff to it. So if a figure is a line, then it contains at least 2 points. So we didn't just say if it's a line. We brought in the word figure. It's a shape, something like that. If a figure is a line, then it contains at least 2 points. So the inverse of that, remember, inverse is going to include nots. It's going to negate the hypothesis and conclusion. So if a figure is not a line, then it does not contain at least 2 points, right? Not here and not there, making it an inverse. Inserting knots into it to make it an inverse. Converse, we switch the hypothesis and conclusions, the front to the back, back to the front. So if a figure contains at least 2 points, then it is a line. And then the contrapositive to that is going to take these two, put them together. So in the order of converse, but with negations in it. So a figure does not contain at least 2 points, then it is not a line. And one thing about it, whenever we create the inverse, converse, and contrapositive, we don't always make a true statement. Right? If a figure contains at least 2 points, then it is a line. So there could be a plane that has at least 2 points. It's going to have 3, 4, 5 points on it. So just because it's got at least 2 doesn't make it a line. So not all variations of the conditional statement are going to be true statements. And then lastly here, decide whether the statement is true or false. If it is false, give a counter example. So A, 3 points are always contained in a line. So a line could have 3 points in it, could have more than 3 points in it. But whenever I have 3 points, are they always in a line? If I have A, B, and C, I have 3 points there, but only 2 of them are on the line. So just because there's 3 points does not mean that they're going to be in a line. So that one would be false. So we can come up with a way that that statement's not true. And last one, a line can contain more than 2 points. All right. There has to be at least 2 points in it to make it a line. But the longer the line is, the more points there are on it. And since a line extends both directions forever, it can definitely contain more than 2 points. So this one is true. All right, so that completes section 2.1.